Astronomy Cast, episode 257 for Monday, March 19th, 2012. Viking Orbiter. Welcome to Astronomy Cast, our weekly facts-based journey through the cosmos, where we help you understand not only what we know, but how we know what we know. My name is Fraser Kane. I'm the publisher of Universe Today, and with me is Dr. Pamela Gay, a professor at Southern Illinois University, Edwardsville. Hey, Pamela, how you doing?
I'm doing well. How are you doing, Fraser?
Doing really well. We had a bit of a delay. Apologize to everybody, but you were on a crazy conference.
I was. So last week I was at the Lunar and Planetary Sciences Conference down in the Woodlands, Texas, otherwise known as a rich part of Houston. And I was catching up on all that's new and amazing in space science, and I was reminded that we started almost 50 years ago from this recording. It was actually in April that it happened. We started putting spacecraft past other planets 50 years ago, April 2012. So doing this show makes perfect sense.
And I would say that conference is one of the biggest news generators of the entire year. We are still digesting the news that poured out of that conference. And there's some really interesting things that came out of it. So, yeah, I know Nancy.
Yeah.
Nancy's got a list of articles that she's planning to write. That's an article.
Right.
Yeah.
Yeah, Emily does too. So check out Universe Today, Planetary Society blog, and I have a far smaller number but long stories on starstrider.com.
That's great. All right. So let's get going then. So Spirit, Opportunity, and Curiosity get all the news now, but it was NASA's Viking missions that gave us our first close-up view of the surface of Mars. This twin mission, orbiter and lander, set the stage for the exploration of Mars, demonstrating that we could actually reach the surface and study the soil up close. Today, let's talk about the Viking 1 orbiter. So this is I think a lot of people don't really realize when they talk about the Viking, they always think about the Viking lander. And they always think about that crazy spider-looking spacecraft with the big scoop that was digging up soil off the surface of Mars, searching for life. But really, it was a two-part mission, and so we wanted to break it up into two pieces and talk about the intro part, the orbiter that really helped capture some of the greatest pictures of the surface of Mars, many that are still used today.
So these are part of actually the Mariner spacecraft program, and this is one of those confusing things. It's sort of like the auto industry sometimes renames a type of car or switches branding along the way. And the Mariner program, which started with Mariner 2 as the first successful one doing flybys of all the inner planets, eventually evolved to include Voyager 1 and 2. The Cassini mission eventually was also based on the Mariner spacecraft. These are just upgrades on the same spacecraft over time. They're these basically beetle-shaped spacecraft that have 4 solar panels, an octagonal shape that allows instruments to go on the various sides. And with these Viking 1 and 2 missions, both dedicated to going to Mars, they weren't just the orbiter, they were also the lander as well. And what was neat is the whole kit and caboodle headed off, and then it was once they got there they realized the landing sites they hadn't picked out were necessarily the places they wanted to land, because with the wonderful images that for the first time we were able to get, they realized that they were planning to drop Voyager 1's lander into a rather dangerous part of the soil of Mars. So there's actually a fairly significant 16-day delay in when we were able to put the Viking 1 lander on the soil. And the amount of, oh, wow, that's not what we expected that these two missions encountered was really quite amazing.
Yeah, I think a lot of people don't realize. We talk about Cassini and Mariner and Viking and all of that, but it really was just this class of spacecraft, and we actually talked a bit about that in the Mariner program episode, just how ambitious their plans were originally. Even the Voyagers are all part of the same class of spacecraft, and they had tremendous plans, which of course, as always, get cut back, and missions get renamed and all that. So
these are really the Land Rovers of NASA. These are the spacecraft you load up with all of your instruments, and instead of taking off across the Gobi Desert with extra fuel tanks, you're taking off across the solar system, occasionally with a radioactive thermal power source. So all of these different missions shared similar hardware, similar layouts, but with the Viking missions, I think for the orbiters at least, the most amazing things that they had to contribute were their cameras. These were the spacecraft that caused scientists for the first time to wonder, did Mars once have rain? And it wasn't actually until Phoenix went and revealed ice that we were finally able to end this argument. So Mariner 9 had orbited Mars for a good long time, and in fact Valles Marineris was named after the Mariner spacecraft because, well, the one revealed the other. But it's one thing to reveal a giant canal, not canal, I mean that's what Lowell claimed
chasm,
it was,
yeah.
but chasm, to reveal a giant chasm. And it's another thing to say that looks like the Grand Canyon enough that we think it was probably created by water. So with Mariner 9, we were getting back images sufficient to say, oh, wow, large volcano. Oh, wow, large something broken into the soil that looks like a giant canyon. But when Viking 1 and 2 got there, they were able to, in some cases, get images with 8-meter resolution. And this resolution was sufficient to, unfortunately, not end the face on Mars debate. That would have to wait till modern spacecraft got there. But it was sufficient to start doing things like revealing what looked like islands with teardropped land behind them that could have been formed by water racing across the surface and causing erosion around slightly harder soils. The images from Mariner were sufficient to see that there were craters that appeared to have runoff that cut channels through the crater walls. It was sufficient even to reveal craters that looked like they might have formed in mud. Now, this opened a whole lot of debates about fluvial versus aeolian factors, which is a fancy way of saying, was it water or was it wind that created these things? And it was kind of amazing to watch all the way up until 2005, scientists jump through amazing hoops to try and blame all of these things on the wind.
At the time that I'm recording this, actually, I was just writing an article about something a really strange weather pattern on Mars that can only be formed by the wind. So the wind is the thing that's still going, very powerful wind on the surface of Mars, and it's still transforming the landscape of Mars.
Right.
But it's this whole idea that a long time ago you had these ancient oceans, ancient rivers, lakes, really active water going on the surface of Mars. And the question was really, did that really happen, and when did it switch over? And so this was this problem. You had all of this spacecraft that it gave you half of the story, but it wasn't conclusive.
And what was interesting is as they kept looking at the surface of the planet, they kept revealing new features that left them verklempt, for lack of a better word. There's this amazing terrain, and we reuse this phrase a lot for different bodies. It's called chaos terrain. You hear about the chaos terrain on Europa. This is areas where the ice structure is all blocked up and jumbled together, and it really looks like someone took the surface, hit it with a sledgehammer, and shook it in a pan, and then left it there in this broken, shattered, chaotic formation. And it's one thing to see how this would happen with ice, and there's some great research explaining that it's just hydraulic forces break it up, it breaks and shatters, and it literally does the shake it around in a pan thing and refreezes. But when you're looking at dirt that did that, this is a bit harder. This was something that has actually led to a lot of struggling. So with the chaos terrain that was revealed by Viking, scientists had to start jumping through amazing hoops. And one of the ideas was that you have this region of soil that is underlaid with ice. And something comes along, melts all that ice, and the terrain that was on top of the ice collapses down. And in the process, because different things melt at different rates, the terrain that was on top of the ice gets entirely jumbled up through this process. But then there were people trying to figure out how to explain what melted the ice.
Right. And so then what was the sort of overall plan for the missions? where did it come from? Because as you said, there was the Mariners and there was this whole Mariner program. So when did it really become, and sort of what turned it into the Viking missions?
Well, so the name Viking really came about because, well, first of all, there was a gap in time between the Mariner mission and launching of the Viking mission. So gaps in time allow you to rename things occasionally. There was also differences in how Congress funded it, which is, for instance, why the Voyager missions got renamed. Is the Voyager missions were actually very, very scaled back from what had originally been planned as part of Mariner. So rather than give the name Mariner to these vastly scaled back projects, they just renamed them Voyager. So the gap in time and then slight changes in technology all led to the renaming of it, which basically got people all excited that this is something new, when really it's just something old that has been tweaked. But the reason for it was largely all the discoveries made by earlier Mariner missions. With Mariner 9, we saw these cracks, we saw these volcanoes, we saw these ice caps, and this gets people excited. This was a world that had weather. That was another one of the problems the Mariner missions ran into, is they got there and discovered dust storms. Can't see the surface of the planet.
That was unexpected.
I mean, imagine you launch your spacecraft, it spends 10 months getting there, you're so excited, and your first image comes back and you're looking at dust storms, and you can't see the surface through the dust storms. This was what scientists went through. But this made us realize, wow, this is a world with weather, and we wanted to know just how diverse, how possible for life is it. And we're going to talk about this more in the next episode,
yeah.
But one of the primary goals of the Viking mission was to stick landers on the ground and look for life. With the orbiters, well, they were one part communication satellite, so information was going from the landers through the orbiters back to Earth. They were one part weather satellite. They were one part crater mapper. They were looking at water, looking for storms. They were playing the role of basically, think spy satellite combined with weather satellite here on the planet Earth.
They were vast. They were really just vastly ambitious. When you think about the capability and what these spacecraft did, it seems like it's from the far future that they were able to image the planet at this amazing resolution, that they were able to land there with the enormous delays. I mean, now we just take this stuff all for granted, that we just use computers to land these spacecraft and have them make decisions and stuff. But I mean, they had computers that were no more powerful than your pocket calculator.
Right.
So it's just phenomenal what they were able to get done. So then what was the sort of the order of the Viking missions? Who went first and who got there?
So this was one of those times when number of mission actually matches number of everything else. So Viking 1 launched on August 20th, 1975. It entered orbit on June 19th, 76. Viking 2 launched September 9th, 1975, entered orbit August 7th, 1976. And they sent back data for years. And in fact, it was with Viking 1, it kept going basically until they finally started to run out of fuel, and they adjusted its orbit to make sure it wouldn't crash into the planet. Viking 2 actually had some fuel issues, and it ran out of fuel earlier than expected, so they bumped it also into an orbit to protect it from landing on the planet. But in the interim between getting there and doing there, in the case of Viking 2, over 700 orbits, in the case of Viking 1, over 1,400 orbits, in the case of doing all of these different orbits, they changed their orbit multiple times, which allowed them to change how long it took them to get around, which sounds kind of trivial. but that actually means that they get to change the illumination angles, they get to change when they're closest to the planet, when they're furthest out, because these were often elliptical orbits. And this allowed them to see the surface under different illumination conditions, to see the surface when they're closer at higher resolution, when they're at higher altitude, see it at lower resolution, but also get those landscapes where it appears like you're actually flying over the various huge volcanoes that they had.
And
all of this yielded different science.
Right, and so this is going to be hard to sort of explain on audio, but
Yeah.
you know, when you actually see the spacecraft, you can really see, as you said, they've got these 4 solar arrays. There's all of the scientific instrument on top of it, and then underneath is this carrier shell.
Yeah.
It's like a clam, and so it's holding on to the actual lander. And so there was both of these spacecraft had the same configuration. They flew,
Right.
they had the orbiter part, and then underneath they had this descent module. And so they were actually orbiting Mars for quite a while before they actually released their landers.
It actually wasn't that long. That was one of the things that NASA has gotten really good at doing across all of its different missions. So, for instance, with Viking 1, it entered orbit on June 19th, 1976. The original plan had been to land the lander on 4th of July because, well, NASA likes to land things on U.S. holidays. There's a surprising number of mission events that have happened on 4th of July. But when they got there, this was the mission where they realized, I can't land where we want. So they delayed it all of 16 days, landing on July 20th. So that they were basically in orbit for 1 month before they dropped that first lander. And the story for Viking 2 was very similar. So they just got to business as quickly as they could, getting their landers on the ground, getting their orbital data going, imaging, and trying to make sense of this alien surface.
So what would you say are the major discoveries that the Viking orbiters help make?
The biggest discovery was all of this evidence that there was some sort of a surface erosion process. This is the up until recently water versus wind argument. They saw the chaos terrain that I explained. They saw these water-swept dunes. They saw craters that appeared to have been formed in mud. And this opened up the debate for trying to understand, how do you get liquid water on the surface of Mars? So this was what seeded theorists trying to think out. Was it heavy bombardment by comets that covered the planet in oceans? Was it ice underneath the surface that got violently melted through volcanoes? Was it ice under the surface that got melted when craters impacted? And people continue to struggle to understand, where did all of this water come from? It also opened up ideas to look for shorelines, and this was something we'd never thought of. The Mariner data just wasn't, the Mariner 9 data just wasn't good enough to start imagining, well, oceans on Mars.
And there are these features that are so clearly produced by water. I mean, they look like, if you've ever seen, like, from, up from space, you can see these rivers passing, and they've cut away these little islands inside the river, and they have this really familiar teardrop shape. There are features on the surface of Mars that are clearly looking like that. And so to say that was wind is,
it's really amazing what the desire, there was a lot of water denial going on.
Yeah.
And so listening to talks, you'd hear things like differential hardness of surface. So what you're actually seeing is an area where you have a gully of more easily eroded material, and that's sweeping around things that are harder in material, and they're trying to show examples of features like this out in the American Southwest, and then trying to figure out how to model, well, all of these different things. But the other set of models that people continue to argue over is the slow versus fast. Was there a period of millions of years during which there was water, or was there simply one great event during which Mars basically suffered from Noah's flood, and the entire Valles Marineris got cut away in a matter of days, months, years versus a longer period of time. And it's kind of weird listening to some of these arguments, especially if you've ever listened to any of the Genesis revealed people, because it's just like there's people who try to argue that the Grand Canyon was formed very quickly. These are huge features, and it's interesting to see the gymnastics that has occurred trying to prevent rainfall from occurring on Mars and blame it all on melting ice from catastrophic brief-term events.
But don't they think now that the Valles Marineris is more of an uplift from some of the volcanic processes going on? Yeah,
so that
it's cracking. The Mars is cracking open from the volcanoes, right?
That's a really complicated one. So there there are the canyon features, there are the uplifting features, there are the places where water has run out of it and carved things.
Right.
So it doesn't have one single explanation, although some people will try and blame it on one single explanation.
But now, I mean, we're at the point with Spirit and Opportunity where the evidence that past water existed on Mars is now conclusive, that it was there acting on the surface for a long time. So all of those mysteries, if we could, transfer back to 1976, right, and talk about these missions, these would all be the big mysteries. And this is the great thing about science, right? Now, here we are.
Yeah.
We know a lot of the answers to these questions that must have just kept Carl Sagan up at night.
Well, and what's amazing is, so we've defeated the face on Mars. We have high-resolution images. It's just a cool outcropping. We have figured out, yes, there was water for some period of time that allowed all of these things to form. Yes, there was most likely rain, and we can even start to figure out where the rain occurred and likely for how long based on the different craters. All of these different things I think high-rise data actually has gone in some ways further for creating whole planet weather models than anything else.
Well, that's pretty much the most powerful telescope pointed at a planet in space, like away from the Earth. It's an unbelievable instrument.
It's fabulous. LRO's competitive with it, but let's face it, the moon is not as cool as Mars when it comes to having so much dynamics on the surface. But Mariner opened the door, not Mariner, Viking opened the door for all of these debates and discoveries.
So what was the sort of life of the missions? How long do they last, and how are they finally shut down?
Well, the thing that really caught me is I didn't realize how long they had lasted. So Viking 1, it launched August of 1975, August 20th if you want to get specific. And then just 3 days short of 5 years later, they terminated its operations on August 17th. This mission remained the longest orbital mission going around another planet up until the late 90s. So it just had this amazingly long, rich career of just taking orbit after orbit, and they started to get daring with it through its life, dropping it down to a height of 300 kilometers above the surface, which is roughly 2/3 of the altitude that the space shuttle orbits at. So that's pretty amazing. With Viking 2, as I said, it didn't survive quite so well because it did have this problem with they have to make orbital adjustments, and it ran out of fuel to make orbital adjustments for as long as they expected. So before it accidentally bit the dust, they put it into a parking orbit that would keep it safe. So it got to Mars on August 7th, 1976, and they kept it going until July 1978. So again, it had a multi-year mission. Sent back tons of data across those multiple years. And with these two different spacecraft, they were also able to do other daring and interesting things where they adjusted the orbit of Viking 1 to allow it to get nice close-up shots of Mars moon Phobos. And with Viking 2, they did the same thing, but instead went after Deimos. So they did what they could to expand the science from just looking down to also, well, I guess looking sideways. So looking at the moons as well, trying to understand this odd system that appears to have captured 2 asteroids rather than forming its own moon like we did here at Earth.
It's quite an amazing mission, I got to say. This is one of the ones that I barely remember as a kid. I mean, I was like 5.
Yeah, the thing that I actually have no memory of this mission. I have strong memories of the Voyager missions, and I'm not sure why I missed this one, but yeah.
I have. I'm 2 years older than you, though, so I think so. I have these vague memories of it. Cool. Okay, so next week then we're going to talk about the actual landers and what they discovered, and in fact the controversy that remains to this day. But finally, again, we're going to get an answer to it this summer with the landing of the Curiosity rover, which will then be able to finally try to push that argument to the next step.
You're optimistic.
I am. You think I'm too optimistic? You don't think?
I think people are going to keep arguing this until we've combed the whole planet.
Right, of course. But I do think that Curiosity is equipped with the right gear to at least give people a little more evidence one way or the other.
If it's there, and we can say yes. If it comes back with a null result, they're just going to keep arguing.
That's true. That's true. So I guess they'll keep arguing then. Let's just predict it now. All right, fine. But that's how science works. This is the whole point. This is we could close the book on this. All right. Well, thanks a lot, Pamela. We'll talk to you. We'll talk to you next week.
Okay. Bye-bye. Okay, have to stop GarageBand rather than exiting the Hangout. Have to remember which red button to push. Yeah. So this is the point where while we save, you guys can start typing questions out.
Yeah, go ahead and ask some questions. But like I said, we've got to do a bunch of recording today, so I think we're not going to widen out the Hangout today.
So we'll just take a few questions in text form from the comments, and then jump back to work, and then we will send out a last-minute, hey, we're about to record again.
We're about to record, yeah. Today. Yeah. Save. And don't forget to upload, too.
Right. And if all of you out there could press +1 if you're watching it on the CosmoQuest page, the +1 is hidden down at the bottom of the page. And if you can tell other people about what we do who don't already know, and share out, hey, there's this awesome thing to go listen to. We'd love your shares. We'd love your retweets.
All right, let me see if I can dig up some questions now.
Okay.
People are making fun of my hair. I actually have really curly hair. Yeah, I don't know if you know, but I actually have like ringlet hair.
Oh, geez.
And so if it gets like a little bit long, then it just goes crazy no matter what I do. So yeah, I know it's pretty funny.
Logan has your hair.
No, he doesn't. He has beautiful. My son, he has this beautiful blonde, straight surfer hair.
I remember it as looking wavy. I guess I have bad memory.
So Scott asked if we can get Scott Maxwell on Astronomy Cast sometime. We actually had Scott. We interviewed him. He's the Mars rover driver, and we actually interviewed him for Hangout about 3 weeks ago with Nancy. Yeah. So that's in the Universe Today feed, and it was posted on Universe Today. He's great. Man, that guy interviews himself.
He's fabulous, yeah.
He is so much fun to talk to. He's got the most amazing stories. And he's actually going to be, he was the driver for Spirit, which is now defunct, and he was working on Opportunity, but he's been confirmed as one of the drivers for the new Curiosity rover. So we're going to see a lot more of him. And yeah, he's an absolute character. Great guy. Any other questions?
So there's one. Chris Genley is asking, what is the Tharsis bulge caused by? So this is where I have to admit my planetary science is something that improves every day, and it's not infinite. But from what I understand, this is an area that is related to the volcano system that was on Mars, and the entire region is bulged up from all the lava that was underneath and then released itself through the various volcanoes.
Yeah, I mean, there's evidence with Olympus Mons and the other big volcanoes that they were recently active within the last 100 billion.
There's actually some that are saying
300
million.
300 million years?
Yeah. There's some people saying that. Now there's others arguing. People love to argue Mars is dead versus alive. This is the ongoing debate.
Yeah.
But there are those who claim as recently as 300 million years ago there was volcanic activity of some form on Mars.
And there's some really interesting theories about how this is all connected, how the Valles Marineris is connected to the Tharsis bulge, is connected to the thigh bone, is connected to the various mountains, and even some of the interesting theories about how Mars's rotation how its axis might have been changing over time, that the various amounts of mass moving around the planet might have helped tilt it over on its axis and even shift some of its oceans.
Well, and one of the other weird things is there's various amounts of evidence that the southern lowlands are actually caused by one hell of a giant crater. And this requires that level of language.
One hell of a giant crater.
Yeah. So there's this region that when you look at a flat map, it's just this low level area. But if you project the altitude map onto a globe, you realize that it has a round edge, and this actually looks like huge something hit Mars and basically completely reshaped the southern highlands.
Yeah, and this is the kind of stuff that comes out of that conference you were just at, right? This is the kind of news that we digest.
Yeah, we're going to need to do a new episode on Titan based on that mission, based on that conference. Essentially, it's rain on Titan. It's awesome.
Yeah, well, I just did an article about this today, but there's a thought that there's plans. There's 3 Discovery missions that are in the works right now. They've done the short list, and one of them is this thing called the Titan. The Titan.
It's something that goes to Titan, and neither of us can remember its name.
Yeah, the Titan something Explorer. But they're going to land this lander on Titan in one of the lakes on Titan, and then it will listen for the sound of rain falling on the lake, and it will also be looking for rainbows and rain streaks. You know, when you see a rainstorm far away and you can see the streaking. Yeah, so it's going to look for this rain falling in cloud formations and things like that, and it's expected that it should get rained on a bunch of times. But the thought is that there's actually parts of Titan that don't see rain for more than 1,000 years.
Yeah,
and other parts that are more active near the poles.
What's really awesome is with all of this rain and ice and things that we're starting to see on Titan, we're realizing it's a full ecosystem that we're just starting to try and understand. And if we can start to get a handle on it, it's actually a lot simpler than Earth's, because it's just one giant convective cell that's basically moving the air from the pole that's illuminated to the pole that's not and back again. And so it's a simple system, but it flips on its head every time it goes from northern winter to southern winter.
Now, someone just asked in the comments, and I actually haven't done a story on this, about some weird cloud formations on Mars. There's actually Julian Poitier asked this. There's actually 2 stories about this. One, there was just these weird high cloud formations. We actually had a story on this on Universe Today. But the other one I've seen as well, and I haven't actually done an article on this. There's this strange cloud that's sort of seen on Mars in profile. And maybe I'll dig into that. Did you see that?
I have to admit, I saw people grumbling on the social media about new clouds on Mars, but Mars has active weather, and clouds on Mars, I haven't heard any of the planetary scientists excited about this. So I think it's just
the picture that I looked at looked like a cloud image taken by was done by like an astrophotographer. It was done with like a stacked image, and it could have been an artifact or something like that. I mean, it really looked like a stacked image done by an astrophotographer.
We have spacecraft orbiting right now.
Yeah.
If there was something to be excited about, the high-rise team would have released a press release, and they haven't done this.
Yeah.
So I suspect it's just completely normal clouds. It's just sort of like going outside and seeing this giant, gorgeous anvil cloud. You go take a picture of it. But it's just normal weather that happened to be particularly pretty that day.
Oh.
Fraser had muted himself while the phone rang.
All right. It stopped ringing. I'm sure it'll go to voicemail. Okay, cool. Well, I think that was good. I think there was one more question someone had about Mars, and then why don't we break and
Okay.
come back at it? Adam wanted to just know, well, Adam said Adam Alexander asked, there are two big features on Mars, Olympus Mons and the canyon as big as Arizona, which I think we were talking about. That's the Valles Marineris.
Yeah.
What's
and
about them?
I'd love to know how to actually pronounce that. Someday I need to corner someone because it sounds like we're discussing spaghetti sauce.
I just said it. Valles Marineris.
It still sounds like you're discussing spaghetti sauce.
Sauce. Yeah, it does. But I think we mentioned those earlier. So the Olympus Mons, tallest volcano in the solar system.
Tallest mountain in the solar system because the gravity on Mars is low.
Right. And possibly active as recently as 300 million years ago, or maybe even sooner. And Valles Marineris, which is caused by this uplift of the Tharsis region.
Yeah.
Cool.
And the evidence for possible continued volcanism is there's methane imbalance. Now the thing is that methane imbalance could also be caused by life forms. So this is where it gets either you're pro-life or you're pro-volcano. And that's just a weird situation to be in, but
Carl Sagan never had to worry about this.
Both.
Carl Sagan never had to worry about this
life.
methane discovery, but no, I want life.
I want volcanoes too, though. Can I have both?
Yeah, meh. All right. Well, why don't we wrap this up?
Okay.
So we will be back later on this afternoon. We're going to record another episode and wrap up the Viking mission. So sorry we can't give you any more notice.
Yeah.
And then we'll try to. We'll keep you posted on the other stuff that's coming up. All right. Well, thanks a lot, Pamela, and thanks to everybody who's watching. We will talk to you all later.
Sounds great. I'll talk to you later, Fraser.
Bye.
Bye-bye.